So in this video, magkakaroon din tayo ng quick review on the mole concept and stoichiometry. Okay? So, define muna natin kung ano yung mole. So, 1 mole of a substance means it contains 6.02 times 10 to the 23rd particles or molecules. So, this number is known as the Avogadro's number or N sub A. Okay? So, kapag ka 1 mole yung substance mo, ibig sabihin, ganyan karami yung particles or molecules dun sa inyong system. Okay? So, paano natin ito natatranslate dun sa ating mga molecules or sa mga compounds? Okay? So, consider 1 mole of methane, for example, CH4, ang kanyang molecular formula, inside a 1 liter container. So kapag meron tayong 1 mole of methane, ibig sabihin, meron tayong 6.02 times 10 to the 23 molecules of CH4. Okay? So gano'n naman karami yung carbon at gano'n karami yung hydrogen. So there are 4 moles of hydrogen, ibig sabihin meron siyang 4 times 6.02 times 10 to the 23rd particles or atoms of hydrogen. Tapos meron tayong 1 mole of carbon. Okay? Since meron tayong 6.02 times 10 to the 23 moles ng ating CH4, times 4 yung amount doon ng hydrogen at times 1 lang yung amount doon ng carbon. Okay? So, molar mass is the mass of 1 mole of particles or molecules. So, kapag titimbangin natin yung 1 mole ng CH4, that would be the molar mass of methane. Okay? So, molar mass values can be found in some periodic table illustrations and other literature. So, common data naman itong ating molar masses. So, madali siyang makita. So, per atom, meron tayong designated molar mass. Okay? So, again, molar mass is the mass of 1 mole of atoms or molecules in your system. Okay? So, as an example, let's calculate the molar mass of methane. So, yung molar mass of methane is equal to the molar mass of carbon and 4 times the molar mass of hydrogen. So, yung 12.01 grams per mole, that's the molar mass of carbon. Yung 1.008, that's the molar mass of hydrogen. So, times 1 lang yung carbon kasi isa lang yung carbon sa CH4 and 4 times yung hydrogen kasi apat yung hydrogen sa ating CH4. So, therefore, the molar mass of the CH4 molecule is 16.042 grams per mole. Okay? So here we have some sample problems. So for number 1, calculate the mass of 0.25 moles of sodium hydroxide or NaOH. So for the first step, calculate muna natin yung molar mass ng sodium hydroxide. So yung sodium hydroxide, meron siyang isang particle o isang atom ng sodium, meron siyang oxygen atom at meron siyang hydrogen atom per compound. Okay? So the molar mass of sodium hydroxide is 1 times 22.99 grams per mole for sodium plus 1 times 16 grams per mole for oxygen plus 1 times 1.008 grams per mole ng hydrogen. So the total is 39.998 grams per mole. That is the molar mass of your sodium hydroxide. Okay, for letter B, calculate the mass of 0.25 moles of sodium hydroxide. So para ma-convert natin yung number of moles sa mass, gagamitin natin yung molar mass. So 0.25 moles sodium hydroxide times yung kanyang molar mass. So dapat nasa itaas yung mass, nasa ibaba yung moles para makakancel yung unit ng moles. So mangyayari kapag minultiply natin siya sa molar mass, we will get 9.995 grams of sodium hydroxide. Okay? So for the next example, calculate the number of ethane molecules if its mass is 30 grams. Okay? So mass yung given, i-convert muna natin siya sa number of moles and then i-convert natin yung number of moles sa number of particles. So first, calculate muna natin yung molar mass ng ethane. So ethane is C2H6, so ibig sabihin may dalawa siyang carbon at may 6 siyang hydrogens. So the molar mass of C2H6 is 2 times 12.01 grams per mole for carbon plus 6 times 1.008 grams per mole for hydrogen. So total is 30.068 grams per mole ethane molecule. So ito na yung molar mass ng ating ethane. So for the next step, calculate the number of C2H6 molecules. So from the mass, i-convert muna natin siya sa number of moles by multiplying 1 mole of C2H6 per 30.068 grams C2H6. So that's the molar mass of ethane. So binaliktad lang natin para nasa ibaba yung mass at makakancel siya. So ang matitira ay yung unit ng moles. So meron na tayong moles ng C2H6. And then, imumultiply natin siya sa Avogadro's number. Kasi 1 mole of C2H6 means it has 6.02 times 10 to the 23rd molecules. Okay? So makakancel yung moles ng C2H6, ang matitirang unit ay molecules ng C2H6. So kapag inoperate natin itong expression na to, makukuha natin ay 6.006 times 10 to the 23 molecules of ethane. Okay? So here we have the summary of the interconversions between the mass, the number of particles, and some other parameters of our molecule or atom. Okay? So if we need the mass from the number of moles, kailangan lang natin ng molar mass. if we need the number of particles from the number of moles, we just need the Avogadro's number. So kung gusto nating malaman yung number of particles from mass, dadaan muna tayo sa number of moles through the molar mass, and then convert natin to number of particles using the Avogadro's number. So ganun din kapag kailangan natin ng mass from the number of particles. So Avogadro's number muna to determine the number of moles, and then gagamitin yung molar mass para makuha yung mass. Okay? So for other parameters, kung gusto nating malaman yung pressure or volume ng gas, kailangan lang natin gamitin yung ideal gas equation, okay, or other equations of state, pero ang gagamitin lang natin sa Chem 18 ay yung PV is equal to nRT. So malalaman natin dyan yung pressure or volume kapag given yung ibang parameters like yung temperature. Okay? So now I'll discuss stoichiometry. So stoichiometry is a technique or a way of predicting the amounts of substances participating in a chemical reaction or any chemical transformations. Okay? So a prerequisite is that the chemical reaction must be known and the chemical reaction must be balanced. Okay? So yung balancing chemical reactions, hindi ko na siya i-discuss dito. Okay? It can be found, or the techniques can be found in other resources. Okay? So ang gagawin lang natin dito ay magpe-predict tayo ng mga amounts of products or reactants depende dun sa given dun sa problem. Okay? So for the first one, let's predict the amount of reactants or products given the amount of one component. So ito yung isang case, okay? Given yung amount ng isang component, ipapredict natin yung amount ng ibang components. Okay? So for example, calculate the mass of water produced in the reaction if 10 grams of methane is made to react with oxygen through combustion. So given yung ating chemical reaction. So methane reacts with oxygen to produce carbon dioxide and water. So yung reaction na to ay hindi pa balanced. So the first step is to balance the chemical reaction. So kapag binalance nyo siya, you will get 1 molecule of CH4 reacts with 2 molecules of oxygen to produce 1 molecule of carbon dioxide and 2 molecules of water. So this is per molecule of methane. Okay? So for the second step, let's predict the amount of water using the balanced equation. So start tayo dun sa mass. So 10 grams of methane. So yung methane or yung mass ng methane, i-convert muna natin siya sa number of moles. So gagamitin natin yung molar mass. So dapat nasa itaas yung 1 mole, nasa ibaba yung 16.042 grams which is the molar mass para makancel yung units ng mass. So kapag alam na natin yung number of moles given this, okay, pwede na natin i-relate yung amount ng water sa amount ng methane doon sa balanced reaction. So makikita natin na per molecule of methane consumed, meron tayong 2 molecules of water produced. So per mole ng methane, meron tayong 2 moles ng water na mapoproduce based on the balanced reaction. So that's 2 moles of water per 1 mole of methane. So makakancel yung moles ng methane. So matitira ay yung moles ng water sa units. So ko-convert na natin yung amount ng water sa mass. Okay? So 1 mole of water tapos 18.016 grams of water. That's the molar mass of our water molecule. So kapag inoperate natin, makakancel yung units ng moles, matitira ay yung grams water. Okay, so kapag kinumpute natin, makukuha natin ay 22.461 grams of water. So na-predict natin yung amount ng water na mapoproduce given the amount of the reactant which is the methane molecule. Okay? So for the next one, let's predict the amount of products formed given the amount of both reactants. So kung given na yung mga amounts ng mga reactants nyo, you have to decide kung alin sa mga reactant amounts na yon yung gagamitin natin para ma-predict yung amount ng products. Kasi hindi lahat sila ay mako-consume. Okay? So we have the limiting reactant. So the limiting reactant is the one totally consumed after the reaction. Siya lang yung nauubos after the reaction is finished. Okay? So the amount of product formed depends on the amount of this reactant. So kasi limited lang yung amount ng reactant na to dun sa reaction. So dito lang din malilimit or yung limiting reactant yung maglilimit sa amount ng products formed. So we have to determine kung alin yung limiting reactant. So the rest of the reactants will be the excess reactant. Okay? So the excess reactant is the one not totally consumed. So may matitira tayong excess reactants. From the word itself, excess. So may matitirang reactants after the reaction. Ang mauubos lang ay yung limiting reactant. Okay? So for example, predict the mass of water formed if 10 grams of methane reacts with 10 grams of oxygen gas through combustion. Also, calculate the mass of the remained excess. Okay, so given tayo ulit ng reaction, ang una natin gagawin ay ibabalance yung chemical reaction. So kapag binalance natin, we will have this balanced reaction. 1 molecule of methane reacts with 2 molecules of oxygen gas to produce 1 molecule of carbon dioxide and 2 molecules of water. Okay? So, since given na yung amounts ng methane and oxygen, alin kaya sa kanila yung limiting reactant? Okay? So, for the next step, predict the amount of water formed from both reactants. So, pwede nating i-compute or i-predict yung amount ng water using both the given values of the reactant. So kapag sa CH4, 10 grams of CH4, okay, gawin natin number of moles by multiplying 1 mole of CH4 over 16.042 grams of CH4. So nasa baba yung grams, nasa itaas yung mole. Para ma-cancel yung grams, so we have the moles of CH4. Ngayon, gagamitin na natin yung mole ratio based on the balanced reaction. Okay, ito pala. Okay, so 2 moles of H2O will form per mole of CH4. Okay, so makakancel yung moles of CH4. Okay, ang matitira ay moles of H2O. So na-predict na natin yung amount ng water dito in moles. Tapos, i-convert natin siya sa mass. So, to convert to mass of water, we have to multiply this by the molar mass. So, 18.016 grams water over 1 mole of water. So, cancel yung moles ng water. Ang matitira ay mass ng water. So, the answer is 22.461 grams of water after the calculation. So, kapag sa oxygen naman, we have 10 grams of oxygen. Convert ulit natin siya sa moles of oxygen by dividing dun sa kanyang molar mass. So, makukuha natin ay moles ng oxygen. So, i-convert natin siya sa moles ng water by using the ratio. So, meron tayong 2 moles of water formed per 2 moles of oxygen gas reactant. So, makakancel dito yung moles of oxygen. So, we have 2 moles of water na. So, i-convert ulit natin sa mass of water. So, 1 mole yung water, tapos 18.0 grams siya. So, we have mass of water din. So, ang magiging sagot kapag kinalculate nyo ay 5.63 grams of water. Okay? So, mapapansin nyo that the oxygen is the limiting reactant kasi siya yung nag-produce ng less amount of water. Kasi siya yung mauubos dyan sa reaction. Kasi 5.63 grams lang yung mapuproduce ng water kahit 10 grams pa yung CH4. Okay? So, after the 5.63 grams of water, ubos na si oxygen. Okay? So, siya yung limiting reactant. Si CH4, ang mapoproduce niya kasi ay 22.461 grams of H2O. So, this is the value that is greater than 5.63 grams. So, hindi tayo magpoproduce ng 22.461 grams kasi kulang na si oxygen. Okay? So, therefore, the amount of water that will be produced is limited to 5.63 grams. Okay? So, susundin natin yung amount ng limiting reactant to predict the amount of the products. Okay? So, for the last step, calculate the amount of excess reactant that remained after the reaction. Since alam na natin na 5.63 grams lang yung mapoproduce na water, gamitin natin yung amount na yon to predict the amount of CH4 required. So, 10 grams of oxygen. Okay? So, 1 mole of oxygen over 32 grams of oxygen. So, dito sa calculation na to, ginamit natin yung amount ng oxygen to predict the amount of CH4 that is required. Okay? Pwede rin natin gamitin si 5.63 grams water to predict the amount of CH4 required. Okay? So, ginamit ko na lang dito yung oxygen kasi given siya na value, mas maganda gamitin natin yung given value. Okay? So, convert to number of moles, makakancel yung grams ng oxygen. Tapos, gamitin natin yung mole ratio. Okay? So, yung mole ratio na to, that's the ratio of CH4 and oxygen. So, nasa baba yung moles ng oxygen. So, makakancel yan. So, meron na tayong moles CH4 required. Ang lalabas yan ay moles CH4 required na. So, convert natin sa mass. So, mako-convert natin siya sa mass by multiplying with the molar mass of CH4. So, makakancel yung moles ng CH4. Okay? So, kapag kinalculate natin to, makukuha natin ay 2.507 grams of CH4 consumed. So, makikita natin na hindi na-consume yung buong 10 grams kasi 2.507 grams lang yung required na methane dun sa reaction to consume the 10 grams of oxygen and to produce the 5.63 grams of water. Okay? So for the amount of the excess reactant that remained after the reaction, isusubtract lang natin si 2.507 grams from the 10 grams which is the initial amount of your CH4. So 10 grams of CH4 minus the 2.507 grams of CH4 that is consumed is equal to the 7.493 grams of the methane that remained after the reaction. Okay? So for the next one, we will calculate the percent yield of the reaction. So in the real setting, there are complications. So minsan, the actual amount of products is not equal to the amount of products predicted stoichiometrically or yung theoretical na prediction natin. Kapag kasi ginamit natin yung amount ng reactants to predict the amount of products, we are assuming na nagagastos natin lahat ng reactants or nako-consume lahat ng reactants 100%. Okay? So, hindi palaging ganon ang nangyayari. Actually, minsan lang nagkakaroon ng mga ganong ka-perfect na reactions. In the real setting, bibihira ang magkaroon ng ganong reactions. Okay? So, the yield is usually less. Mas konti yung naproduce nating product kaysa dun sa ating ine-expect na amount. Okay? So, also, not all reactants are consumed as expected. So, kahit yung limiting reactants, minsan hindi siya nauubos due to the factors, of course, that may affect the chemical reaction itself. Okay? So, we have some terms. theoretical yield is the amount of products as predicted through stoichiometry. Ito yung kinakalculate nyong yield. Ito yung pinapredict nyong yield using the amount of the reactants present. Okay? So the actual yield is the amount of products after the reaction is performed. Kapag ginawa mo na talaga yung reaction at bineasure mo yung amount of products, that would be the actual yield. So to be able to calculate the percent yield, we need both data. So the percent yield is equal to the actual yield over the theoretical yield or the stoichiometric yield times 100%. Okay? So as an example, after reacting 10 grams of methane and 10 grams of oxygen through combustion, only 2.47 grams of water was produced. So calculate the yield of the reaction or the percent yield of the reaction. Okay? So nagawa na natin itong problem na to kanina. So let's just go over the steps again. Okay? So ito yung ating given na reaction. First, we have to balance. So nabalance na natin to kanina. We will be using the same coefficients. So next, let's predict the amount of H2O formed from both reactants. So nakalculate natin to kanina. From 10 grams of methane, we will get 22.461 grams of water. Ito yung ating predicted amount. So from 10 grams of oxygen naman, this is the predicted amount, 5.63 grams of water. Since mas konti yung napoproduce from oxygen, oxygen will be your limiting reactant. Okay? So the product is therefore limited to 5.63 grams kasi yun lang yung kaya ng ating oxygen. So konti lang yung supply natin ng oxygen, kumbaga siya yung limiting reactant. Okay? So that is assuming that all the oxygen will be converted to water after reacting with the methane molecule. That's 100% kumbaga na reaction efficiency. Pero hindi ganoon ang nangyari dito sa problem. We have 2.47 grams of water that is produced in the real setting. So since 2.47 grams lang yung na-produce, let's calculate the percent yield. So to calculate the percent yield, we have the formula percent yield is equal to the actual yield over the theoretical yield times 100. So kapag sinubstitute natin yung values, we have 2.47 grams as the actual yield, 5.63 grams as the theoretical yield, okay, times 100% is 43.87%. Okay? So that's the percent yield of the reaction. So this is my video on the mole concept. Supplemental lang siya. So let's proceed to the next video. So see you next video.